All right, in this problem here, we're going to be working on unit conversions, and we're going to be focusing on converting 10 GPM to CFS. So before we can focus on the 10, we need to kind of focus on the units first, remembering that GPM is equal to gallons per minute, right? So what this is saying, it's saying in 1 minute, 10 gallons of water flowed through, say, this pipe in this example. We need to convert to CFS. We need to remember that CFS is going to be cubic feet per second, right? Remembering that this is the same thing as writing it as cubic feet per second or several other different ways of writing that problem. Okay, so let's look at this, converting 10 gallons per minute. What we want to do is we want to focus on the units first. Let's hold off on the number 10. I need to convert gallons to cubic feet. I need to convert minutes to seconds. So we're going to tackle those separately. We're going to start with volume because that's what most students like to start with. So if I'm trying to get rid of gallons, what I'm going to do is I'm going to set up my conversion here. Just like any fraction, if I'm trying to cancel out gallons or get rid of it, I need to put it on the opposite side of my unit conversion here. So gallons is going to go on the bottom. What am I trying to get to, or what am I bringing into the problem? That's going to be cubic feet. So now I need to know, okay, I've got my gallons, cubic feet. Now I need to remember, well, what is the actual conversion factor? So maybe you have it memorized. Maybe you go to your conversion sheet. You know that for every 1 cubic foot, there is 7.48 gallons, right? That's our conversion factor. It's also a good check just to say in your head or say out loud is to say, okay, 1 cubic foot is equal to 7.48 gallons. That'll help you remember, okay, I did in fact set it up right. Sometimes you'll flip the 1 to 7.48. So say this conversion factor out loud or in your head to make sure it makes sense. So what this is going to do, this is going to allow us to cancel out gallons. We're going to be left with cubic feet, which is great. That's what we want. However, we need to tackle the minutes, right? We're converting minutes over to seconds, as you can see here. So minutes being up top, or sorry, minutes being down below here, we want it in the opposite. We want it up top on the other side here. What are we trying to get to? We're trying to get to seconds. So how many seconds in a minute? We know for every 1 minute, there are 60 seconds. Great. So now we're going to be canceling out our minutes here. And what are we going to be left with from a unit perspective? If we look at what's left here, we multiply across the top, we're going to be left with just cubic feet. If we multiply across the bottom, we're going to be left with just seconds, right? And that's what we want. We want to be left with cubic feet per second. Now, if you continue this format here where you're focusing on units rather than focusing on the numbers themselves, more than likely, you're going to get this problem correct. This we refer to more of as a dimensional analysis. We're focusing on the units and not so much necessarily the numbers. So now we can run the math, right? So what does this look like? Well, we're actually taking 10, we're dividing by 7.48 because it's on the bottom, and we're dividing by 60 because that's on the bottom. So if I type in 10 divided by 7.48, I'm going to divide by 60, I get 0.02228, or in this case, I'm just going to say 0.02 cubic feet per second.